Hi, everybody. Okay, you are going to need today a pink, orange, and yellow highlighter. You're going to need a skinny black marker, and these should be on the trays at your table. If you don't have these items, pause the video, get up, go back and get it, go straight back to your desk. Don't talk to anybody on your way there or back, and then start the video again. You're also going to need your green binders so that you can pull out your Chapter 3 annotations, and then you also need your iPads. Once you have all your supplies, let's get started. All right, so I just want to remind you, yesterday, go ahead and take a look at page 7 in Chapter 3, and you should have these annotations already. But we were talking about, like, what are the conditions or what things have to be in place in order for a tsunami to occur. And in the very first paragraph on page 7, we annotated 4 different things. We identified 4 different variables. First of all, there has to be an earthquake that causes the tsunami, not just any earthquake, and we'll get into that in a second. The magnitude of the earthquake has to be at least a 7.0 on the Richter scale. Also, that earthquake has to take place under the water or very near the water. And lastly, the type of plate boundary involved has to be convergent. So we annotated, if you look on page 8 and, page 8 and 9, possibly, we said the convergent plate boundaries are the only ones that we will find tsunamis at. Divergent and transform plate boundaries, there are no tsunamis there. Also, you all are going to get a map that shows the Indian Ocean region. This map is what you guys are going to be working on today. This is also on your tray. I'm going to work with you to mark up the map, but it's going to be up to you because I'm not there to show you step by step. If you have questions, you guys, you can ask anybody that was in periods 1, 2, and 4, and they can help you. But I'm going to explain it so well that you guys are going to get it, okay? First thing I want you to notice is that this is a map of the Indian Ocean, and it is divided up into square coordinates. At the top, you'll notice that these are lettered A through N, and then on the right, they're numbered 1 through 11. So we can have coordinates, for example, A1, and you would be working inside the square for A1. Also notice your key on the left-hand side. The key is actually divided up into 2 different pieces of information. The first thing that we're going to identify on this map are the different plate boundary types. We're going to try and identify where there are convergent plate boundaries, divergent plate boundaries, and transform plate boundaries. And then I'm going to take you into the tsunami alert computer simulation, and you are going to mark different earthquakes, where they occur, and what kind of earthquake they are. So you can see that we'll mark just a regular earthquake that does not cause a tsunami. We're going to mark that just with an open circle. And an earthquake that causes a local tsunami will be a half circle, like draw the circle and then color it in half. And then earthquakes that cause an ocean-wide tsunami will be colored all the way in. So when you're done, you're going to have really good data on this graph that you're going to use to place your sensors when we start on Tuesday. Remember, we don't ever want to just randomly just start throwing sensors out willy-nilly just to see what happens. That would cost your company a lot of money, and you probably would get fired. So we have to have educated guesses about where we think the best location and the different types of sensors that we use are going to be. And this is really, really important. This map of the Indian Ocean is really important to help us get to that point. Okay, so just a reminder, if you go ahead and turn to page 8 and page 9, we know that convergent plate boundaries are associated with 2 different landforms, trenches and mountains. And divergent plate boundaries are located with mid-ocean ridges. So on your map, go ahead and take a pink highlighter and color the word convergent. So we're going to find some convergent plate boundaries and we're going to mark them on the map using pink. Divergent is orange and transform is yellow. So again, we are looking on your map for mountains and trenches that are close together. And so we're also going to go back to page 7 and remind ourselves that purple line already gives us an indication of where underwater earthquakes occur. And the red marking there indicates areas that are at high risk for tsunamis. So we're using this background information as well as what we can see with our eyes, and we're going to mark the convergent plate boundaries like this. So go ahead and copy what I have. You can see that this map has taken all the water off the surface of the earth and all the vegetation. So what we're looking at is Earth's solid surface. And from Oman, Pakistan, and then to the left side of India, we're going to just draw that horseshoe. You can see the trench, and then right up there where Pakistan is, those are mountains. And so this is a really good location for us to say, for sure, this is a convergent plate boundary. And then to the right of India, and actually, if you go all the way down to Sri Lanka, you can see that trench, and the trench forms all the way up and around India. But we're also looking for mountains. And so there's no mountains in between India and Sri Lanka, but on the west side of India, we do see mountain ranges. So we're going to start there and then come all the way around, and we'll hook down by Sumatra. So again, we can see these trenches easily, but we're looking for a combination of trench and mountain. So this is our location for convergent plate boundaries. Next, we're going to look for the divergent plate boundary, and it's pretty easy to locate that on our map. You see that area that I have marked on my orange. It looks like a giant scar. And remember, that's when the plates are moving away from each other so incredibly slowly, and new solid rock is formed as those plates get pushed away from each other. And so what we have left is this giant, almost scar-looking landform, pretty easy to identify. So right now, if it was just this, and I would say to you, where would you not put your sensors? We know that divergent plate boundaries do not cause tsunamis, and so you're pretty confident that you wouldn't put them along that divergent plate boundary. What about transform plate boundaries? Well, unfortunately, there's no notable landforms, and so we can't mark anything on here. So there's nothing that we can mark. This is where we're at. Let's go ahead and take a look at our earthquakes now, okay? I'm going to have you pause the video. Actually, I think I'm stopping this video, and I'm going to make a new one, and hopefully you can do a split screen. If you're unable to do a split screen, watch mine all the way through, and I might even tell you, hey, if you can't do a split screen, stop it, and then you can work on your own and then come back to the video, okay? All right, go ahead and open up the second video in your folder.